All right, last little bit on electron configuration. So when we look at these guys, we can start seeing that the D subshell has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons that can fit in that D subshell. That's why we have 5 orbitals. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. Now, with that being said, we come up here and we go 1, 2, 3, 4, 5. Notice my 4s2 is already there. 1, 2, 3, 4, 5. So we'd come over and we'd say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, that's 7 total. That's the 5th one right there. That's manganese. Now, when we get to manganese, something changes here. So all these guys up to manganese will have a +2 charge always, then possibly a +3, a +4, a +5, a +6, or for manganese, we can even have a +7 charge. No big deal, they're multivalent. They can lose all the amounts that they have. Once we get to iron, something kind of funky happens. All of a sudden, iron, the protons in the center have gotten big enough now, and we now have ourselves our first doubling up. What happens now is iron, it doesn't go from a +2 all the way to a +8. It pretty much stabilizes as either a +2 or a +3 charge. It's only going to lose these two or that one right there, depending on what it's bonding with. And so once we get past manganese, all of a sudden, the +2 oxidative state kind of stabilizes. Now, with that being said, something else happens as we get over here with copper and silver. Once we get over to copper and silver, if you notice all of them, both copper and silver, they will have a 3D9, 4D9. Something happens there. The positive charge in the center has now gotten very big. We want to maximize attractions. And so one of these electrons might come off and come over here. So now we've got a 4s1, 3d10. Now, that means that copper, if this is the situation, copper can have a +1 charge, no longer +2. And that's because one of the electrons from the S energy level got pulled into the D to maximize those attractions. So that means only this guy might get pulled off, so copper could have a +1 charge. Copper could have a +2 charge also, and it's typically the 2 states it has. Silver, on the other hand, 4d9, 5s2, does always get that electron pulled in, and so silver only has a +1 charge. All this shielding here, only that one has the ionization energy low enough. Outside of that, we look at zinc. Zinc has a 3d10, 4s2, and zinc does not have multivalence. Zinc is always a +2 charge. Only those two can leave. So we do not have to write zinc 2 chloride because it always has a +2 charge. So we don't need to tell the author that. We just say it's just zinc chloride. Outside of that, there's not a lot of other real anomalies. Cadmium is always a +2. Copper can be a +1. Silver's always a +1. That's about it.